I don't know if it was just the fact that I got multiple at the same time. Maybe I ended just because he said one thing. Yeah, no, it highlights your name, yeah, on the side.
Okay.
Just one. Yeah, it's kind of it's getting a bad reputation.
So, ladies and gentlemen, today we are going to continue on a discussion of issues related to software quality and quality assurance and broadly testability as well. Within today's lecture, we're going to be talking about a key element that enables software testability, which is the use of software contracts, or as they're often called, software specifications. I know that some of you have seen this material, or elements of this material in other classes. In which case this will reinforce and make more concrete and specific what I'm looking for in terms of your deliverables. It will also be emphasized because it plays such a key role in helping people coordinate on larger teams. Okay. So you'll recall that in the area of testability last time, in our discussion of sort of key principles from the first time, we covered them in class in the review of Pop Quiz 1. I listed a number of factors related to testability, and indeed that was a large part of a lecture a couple times back. These included separation of concerns in general, so by testing this part of the system, you don't have to test the whole system with it. You can actually test different components. Writing tests first before writing code to help focus your understanding of what that code needs to do in order to make sure that the tests keep up with the code and to ensure that the tests actually work. Mocking, we've talked about use of assertions, logging and profiling, hooks of various sorts. Today, however, we're going to be focusing on this top issue, specifications, which certainly I would list up there as one of the foremost and perhaps the single most important of those factors. So our software is complex, and it's growing in complexity over time. Just as one of the biggest determinants for the success of an organization is its ability to manage risk, much of that risk comes from the area of the growing complexity of software. And the organizations that can build effective, larger scale software with manageable amounts of risk, with high productivity, are the ones that have often reaped the benefit in terms of first mover advantage in the market, in terms of securing market share. And our software is complex, not just because it has many pieces, but because the interaction between those pieces is complex, and it reflects complexity within our teams. Now, modularity, this division up of software into pieces that are well-defined, that have clarity as to their purpose, and which can be replaced by other components where needed, is a key component of managing this complexity. So we talked about separation of concerns, dividing up, say, the UI layer from the business logic, the logic that sort of has to do with the key reasoning about sort of the concepts you're working with, and dividing that up from the data storage layer, for example, or dividing up model, separating it from view and the controller from the perspective of getting UI actions from the user. There's many advantages that extend from modularity. one of the most important for you folks and for coordination within your teams and allowing, a 12-person team to be far more productive in principle than a 4-person team, is that if you achieve modularity in your software, you can have a kind of divide and conquer strategy where different parts of your team work on different areas of the software, right? So it's not just all one big tangled mess, but rather you can have different people working on different components of it. It turns out that also supports modification and supports ways of, in many cases, of reusing components of the software as well. So modularity is a key asset within building larger scale software. And it helps at the level of code creation in the first place, modification, testing, debugging, review, and specialization of the staff, having different people working on different components. We can test more readily because the understanding is there about what each component has to do. We can debug it by focusing in on one component and mocking out others, for example. We can review those pieces at a time without reviewing everything, etc. Now, it turns out that in turn, to achieve modularity, there's this real need to drive towards something called abstraction. And this term abstraction is used colloquially in different terms in different ways than we use it in software. But basically, it's about putting aside details, abstracting over certain details, as we say, in order to treat many particular sort of cases as fundamentally the same. Okay. So we recognize there's a lot of commonality among these cases, and we provide an interface that captures that commonality. So we can reuse this common abstraction, this common mechanism for many different particular instances. And the differences of the context can be characterized there so that we reuse the abstraction in a way that's general, but it can be tailored to particular contexts. And there's basically two ways of doing this that we very commonly use, as articulated by Liskov and Guptag in a key seminal book in this area. Now, number one, we can have what's called abstraction by parameterization. In this case, we take a method that has logic that's used from many places in our programs, and we create, say, a method from it that takes different arguments to indicate its different needs, right? So maybe you have logging occurring at many components of your program with different details about the level of severity or priority attached to that logging, different details about what to log. And we have a common underlying logging mechanism that we call from those many places, right? And we tell it what's the priority of this logging, what to log in different cases, and we call off and request that logging rather than manually printing it out at every place. And that common logging mechanism has the logic to disable and enable the logging at different levels of severity based on user specifications. So abstraction by parameterization allows us to reuse a single mechanism from many places by passing it parameters. In this case, level of urgency of the logging and the item to log. And it lets us reuse that from many different places. So that's an abstraction, the logging mechanism. And we can use it for many particular instances by passing different parameters. But what we're going to be concentrating on today is this second thing, abstraction by specification. And here, rather than trying to generalize things by passing in different parameters, we're instead going to be putting in place interfaces, contracts, software contracts, specifications that are going to separate implementation from interface. And that will allow many particular different implementations, many particular concrete sort of ways of writing this code to be exchanged over time as performance needs or other requirements entail. Okay, So I'm not going to go much into this abstraction by parameterization. Suffice it to say that there's many ways we use it in different languages. In modern languages, where you have type parameterization, like you see in Java with generics, C++ with type templates, are another way that we achieve it. But our focus today is abstraction by specification. And this is all about separation of interface on the one hand from implementation, okay? And what you're hiding, remember, all abstraction that we're dealing with here is a matter of hiding certain details. Hiding details. So logging hides the exact detail, for example, about exactly how we handle different levels of priority of logging or where that logging goes when it's output. That's something we hide from a particular use of it. And so we just call off the logging mechanism and it takes care of that. With specification, what we're hiding is differences between different implementations that still make use of the same fundamental interface. They still implement the same interface. They just do so with different degrees of performance or different details in the algorithms they use, etc. So it turns out this gives a lot of benefits. It gives the benefit of locality. We can build one piece without worrying about another. We can change one piece of the project without breaking other code. This is key. By this first one, if we haven't written the implementation yet, that's fine, because we have the interface, we have the contract, we have what that implementation will guarantee, we have what it will accomplish, even though we don't have its implementation yet. And other parts of the program can use that information on what it does, even if the how it does it is not yet specified. The implementation is not yet provided. Modifiability, I can be clear about if I'm using this component now, maybe that component has not been written yet, or maybe it has been written, but it may evolve. I can be clear about what I can count on about that component going forward. As that component might evolve, there are certain things, certain aspects of what it does that I should be able to count on. And these specifications we're going to be talking about, the separation of interface from implementation, allows us to be clear about what we can count on. Okay, and then finally, there's some benefits in terms of reuse, and we'll go into that less. So a key motivator for this is that things change. One of the big reasons managing a software project over time is so difficult is because of change. What sort of change do we have in software that we have to grapple with? When I say things change, what changes? Give me a few examples of things that change in software that we have to deal with. Yeah.
End user needs.
Okay, end user needs. Yeah. So the need of a given user might change. The perception of that need might change. Who are the users might change, right? We have a client, and that client merges with another company. And because of that, their needs evolve, and exactly who's in the user group changes. So that's good. Ryan, were you going to say something? Yeah. So what other things change besides user needs? Yeah.
Data storage.
Yeah. So the mechanisms available to us in terms of data storage mechanisms. Whether it's new options for storing things in the cloud, or mechanisms for fast network access storage, or storage on our local devices. This is something smartphones have dealt with over time. Differences, in whether they have an SD card included, how big that is, etc. So that's something that might evolve. What other things?
And other web servers involved that could change where they are.
Good. So services you depend on, for example, externally, could change. So external third-party sites you depend on, good. And in general, technology evolves in a big way. Our sense of what's acceptable performance-wise can change. And our learning can evolve about where our code is spending time. You use a profiler and you understand, okay, this area of the code is a real performance bottleneck. And you realize later, we need to really optimize that later than you wrote it in the first place. And, we don't want a change in one part of the program, in one area of the program, to lead to changes everywhere in the program. That way lies madness, right? That's a hairball of a situation. If I change this little thing and it needs to change 100 other things elsewhere, well, you can only imagine that cascade, right? To make those changes, and then you have to change other things. So much of what we're dealing with as software engineers is a need to manage change. And this change isn't blind. Often we get clues from our users as to how their needs might change. Things that they can't commit to long term, but they know now, this is my need. Okay. So it turns out that these techniques, this separation of interface from specification, really aids in dealing with evolution, graceful evolution under the pressure to change, the need to change. And fundamentally, we choose our abstractions carefully. We choose which things we represent in methods whose particular implementation can then evolve compared to being hard-coded into different places in our program. We hide the details of things we anticipate changing frequently, and we have one point to go to for those things so that we only need to modify one place that can be reused from many places in our program. Okay, this is kind of the idea here. Okay, so, we could have different components in our program, here unimaginatively named, where we are using some common logic, some common code, some common reasoning. Here we have some sorts going on, right? And we have that in two different places, kind of hard code. And, rather than doing that, well, if we do that, one issue is that if we change one place, we may forget to update the others. In today's software world, there's some aspects that make it increasingly difficult to actually capture adequately where all these other places are. I remember working, this is a number of years back now, with the Eclipse project, and there were things taking place there that you couldn't just search for to find all the instances. Does anyone know a technology that makes, in today's landscape, there are several technologies circulating which can make it particularly difficult to search a code base and find all places where something is being assumed or something is being done a certain way. Anyone want to mention a technology that can make it difficult to understand, where code lives and when it's executed and so on? Does the term reflection mean anything to anyone? What is reflection? Anyone? You haven't encountered that yet?
Reflection's like when a class is aware of its own properties and its own functions.
Yeah, that's right. Well put, Eric. So if you have software that in some sense is self-aware, it knows its own structure, it can query about and ask about what methods there are, what arguments those methods take, what they return. That's an example of using reflection. And you can do much more than that. You can load code in dynamically with reflection. You can call functions through reflection mechanisms, say using their name as picked dynamically, say from a data structure. So you could say, not just call foo, but you can call through a string that happens to hold foo at runtime. You can at runtime determine what you're going to call from here. So it's not obvious that this calls something, but it does. It's not obvious, you know, the full set of what it's doing. Another mechanism, for example, are implicits in language like Scala. Another one is aspects. In aspect J, some of you may have seen this in 470, where you have these mechanisms for weaving code in many places of a program. Maybe it's logging code or security-related code or transaction code. And it weaves it in many places in your program without it being obvious by reading that code that's being woven into that it's going to be there. So sometimes finding all instances where some logic is being exercised is hard. I mean, this is one of the reasons I'm particularly keen about even eliminating unnecessary hard coding of constants. So maybe right now you're dealing with an assumed size of some dialog box of 100 pixels, and you want to change it to be 200 pixels. What's to stop you from, suppose that in your code you have it hard-coded at a number of places as being 100 pixels wide. How could that be hard to change to 200 pixels? Anyone? Yeah.
Having heard somewhere doesn't immediately reflect that that's the one variable that we want to change. Maybe something else is also 100.
This is a great statement, and my hat is off to you. That is one of the more subtle aspects of this. That, okay, it may say 100, but is this the 100 you care about, right? Or is 100, you know, the max number of items that could be in some drop-down list? Before going and change it to 200, you want to be clear, is this the 100 that matters, or is this a different 100? If it's just hard-coded, you don't know which is which. Another reason is, sometimes it's not just 100 that's there, it's 99, 1 minus, 100 minus 1. Or maybe it's twice the value. So it says 200, but that's because it's the size 100, each of whose elements has two elements within it, and therefore it's just someone pre-multiplied it there. So it's not clear if you have values scattered around your code, if they are to be changed or not. You may search for 100 and miss the 200, that's 100 times 2 logically, or you may miss the 99. And in short, if you are trying to sort of casually scan for every place that a certain logic is in place, you often miss certain things. And so you may miss, another case where this logic is used. The ideal thing here that people have done since about the time I was born was separate things out into functions, right? So here in C we might abstract these cases of sorting into a function that we call from multiple places. So rather than having it hard-coded here into our code, we call a single point of responsibility from several places. And then if that evolves, then we can just change it at one place rather than changing it multiple places, right? Less work for us, less worry. We won't find all the instances, greater consistency. Someone can take responsibility for it. We can put it in a separate module. Lots of good things coming from us. But the challenge here is that this is all great, and the ability to evolve this is great. But how are we going to ensure the people who are calling this are, in fact, counting on the right features of this? For example, maybe the people calling off to this, if they just see it as it is now, especially if they're looking at this code, they say, oh, that doesn't bubble sort. I can safely rely on ties after I call this. If there's a tie between some of the values, that the ties will be resolved in the same order. They'll appear in the same order that they came in. The ordering will be preserved. If there's a tie, they won't be reordered. It doesn't matter much for doubles, but it can matter a lot if you're sorting pointers to some data structure where it's based on some properties of the things they point to. The point is, there may be features of what this code does, the sort code does, that users of the sort code, like that are here or here, are counting on. They're counting on some feature of that. And there's a risk here that if we, even though we're using one point of control, that if we evolve it in a way we think is a minor evolution or a natural evolution or a evolution that's low risk, obvious gain, we might break code that's depending on some features of the situation. Quicksort does not observe this situation if they're two ties, they're necessarily in the same order. And now suddenly the code which is depending on it might break. They didn't know that we might change this from one type of sort to another. They can't tell just being called sort and from a signature that this might evolve in this way. They don't know if it's safe to count on that. Do you see that point? That the people who use this, the clients of this, might not know how it's going to evolve, how it could evolve. And so if we make a change we think is low risk, we think it's innocuous, it's a minor thing, we might break code in many places. And that's an anti-pattern. In big pieces of software and software with lots of people working on it, breaking other people's code is not something we want to do. And it leads to changes taking a lot longer time to settle down in a fully debugged way. So the question here is, how do we make this sort of code less brittle? How do we allow it to handle multiple implementations over time? You could argue, and with some reason in today's open source software world, that the folks who use this code, the people who call sort here, they could go look at the implementation. And if you're using open source, you can, right? I can go look at how this thing I call, how it's implemented, right? And I could say, oh, they're using bubble sort, so I can count on this feature. You might think that with reason. I can count on this feature because they're using that particular implementation. What's the problem with that reasoning? Yeah.
Twofold. Even if it is open source, the implementation later might change.
Yes.
And if it's not open source, you can not even look at the code and see what implementation they have.
That's right. So, well put. And your name, young man? Nick is on a roll. I have a problem because I bind names to seats. And I think of Nick as the guy over there. Oh, he's in that seat. And so thank you. Takes a long time. So a key point here, I want to emphasize Nick's first point there. Look, even if that code, you can go check it and say, oh, it's safe to assume this. It doesn't tell us how it might evolve. And it might evolve in a way that violates that assumption later. So even if we check it now, there's no guarantee that it will still be the case if we're looking at the code implementation. Maybe that implementation will evolve in a way that will break our assumptions. Do you understand that point? We might think it's guaranteed now, but 6 months from now, that code evolves, that we're calling evolves, and we're out of luck. And it breaks our code. That way lies madness. We want to be careful about that. So, just the signature, just kind of the, saying, oh, it's named sort and it takes in this and returns that, it's really grossly insufficient. It's not enough to give us the guarantees we want. Not only guarantees about what it accomplishes now, but what it will accomplish in the future, what we can count on as it evolves. We want some way of knowing what this thing does and what it will promise to continue to do. And importantly, what's not promised to us. So we don't count on that. Because if we're counting in our calls on sort of minor features of how sort is implemented, we're counting on little implementation details, we're setting ourselves up for a fall. We're setting ourselves up to be in a bad way if sort evolves in the future. We may fall flat in our face. We have to go and change our code. And that's not fun. When an API gets updated, for us to have to go back and deal with all sorts of bugs that have come up in our code. It's not what we want to be doing. We want to be creating new features to deliver value to the user, make the user satisfied, deliver to new customers. And if we're always fighting fires with the latest API release breaks half of our code base, we're in bad shape. We're in bad shape. Okay. It's not what programmers like to be hired to do. You're going to have a hard time finding really good programmers who get fired up about a job that's just always firefighting. So what we're seeking here is some sort of contract. It's some sort of persistent promise, persistent guarantees provided from this thing to its clients, the clients that use that thing, as to what's guaranteed. What is guaranteed and what's guaranteed now and in the future, even if details of how it's implemented evolve, even if details about the specific algorithms used internally or data structures change. And for years, people have written about the use of software contracts. And these have been examined in a wide variety of ways. And it's led to this whole growth of a practice called design by contract. And a key mechanism for this, a key element that's required in this class, is the use of specifications. It's specifying what we can count on. Okay. So the idea here is that foo and bar, they call off to this code, and this code has some description that characterizes outside the code itself. It has some documentation associated with it that specifies what it does. So given an array of values, returns array consisting of the permuted indices of the elements of the original array, with the ordering of these indices being such that the elements of those indices are arranged in ascending order from smallest to largest. And as a precondition, you can't pass it in a null set of values, and a post condition. Okay, it specifies the return, specifies for each sorted element the index where those elements originated. And it says, and it guarantees ties values with equal value retain their initial order. Okay, so this is providing a specification. You'll notice that it is not promised there what exact sort algorithm is used. You notice it doesn't say whether this is done in a loop or whether it's done in a functional style, using Java 8 or what have you. It doesn't say the language it's implemented in. Maybe this calls off to the JNI, the Java native interface, to code on the local computer. For a more sophisticated thing, maybe it uses your GPU. But what it does do is provide a certain set of guarantees that if you use this in a way that meets these preconditions, you will get these post conditions in place. And it provides a little bit more detail about this. Okay. Now, the goals of this sort of thing are to help manage the risk of change. And it really helps two different broad groups. These are key points. One is the people who provide this abstraction. In this case, the people who provide this code, sorted indices, or provide this code sort. Okay. Why does it help them? Well, excuse me, the ones who use it. So here it's the people who call it here, the clients of it. We'll get to the ones who provide it in just a moment. So for the users, it provides guarantees on which they can count. Not just now, but from now on. They don't have to read the code to understand this, right? They don't have to spend the time studying this code, say, what does it do? And how does this work? And what's this variable? There's no need for guesswork, access to the code base or reading the code, spending the time. And it clearly delineates the assumptions that they can't count on and on which they cannot count. It says, these are the things I guarantee, and if it's not in there, and it can't be deduced logically from that, then you can't count on it. Can't count on it guaranteeing something if it's not promised. For the creators of the abstraction, the folks who create this, it allows them to write the code against the interface before the interface is implemented. So maybe other areas of their program can be set up to call off to this without it yet being implemented. It gives a good guide for testing, what things can be tested, and a clear understanding of what they can modify freely as they improve the performance of the code or otherwise evolve it. And critically, knowledge of what features users are counting, and they can't change that. They cannot change it without breaking user code. So for the creators of the abstraction, it provides an understanding of what their users are counting on, rather than being unclear and just without deliberately doing so, breaking a lot of user code as they update the API. So there's a lot of benefits from these specifications. Conceptual clarity, easier integration of different parts of your program. I see what you're guaranteeing in your code, maybe before you write your code. I can see what you're guaranteeing. I can go off and write my code, which uses your code. You can write components of your code and that count on mine. We can mock it more easily, right? Because with mocking, often we're checking preconditions or we're enforcing post conditions. We have to mock, return something that's at least legal, even if it's not doing the full, providing a full implementation, and provide something that's legal and it's clear what is. There's clear documentation of the requirements, and in some cases, you can do more aggressive optimization because it's clear what this guarantees. And in general, it's easier quality assurance. And despite the costs, it takes time to write these things. There's no denying it. But there's often long time savings in terms of shorter debugging time, testing time, and more efficient division of work between those on the teams. Okay, so these sort of specifications are of great benefit. And they're particularly valuable for the detailed design early on, where you can often lay these out. You can directly derive assertion checks. Look, if it's a precondition, assert it at the beginning. If it's a postcondition, make sure it's true at the end. Makes for obvious sort of assertion checks. If you have these in place, as I said, you can mock things out. You can put, for the testers on your team, get them working early. The code may not be implemented, but you should be able to put in place tests based on the specification, because you're seeing what is supposed to be guaranteed. The testers can get going on it in parallel with the developers, not waiting for the developers to throw the code over the fence to them. And it turns out there's less risk of violating the Lisco substitution principle, which is a key principle that comes into place with safe subtyping. And the ease of reasoning here lowers the risk of error, eases the speed of development, debugging, and testing, and with greater clarity, performance. Okay, so what do these contracts look like? Well, basically they're an agreement between the implementer and the provider of these contracts, and they're described by specifications. There are formal contracts out there. I know Professor Dutchin in some classes, in 340, for example, introduces provable software or Hoare logic that can help reason formally about programs. Within the specifications areas, there's ways of using formally sort of testable or formally usable things that can be reasoned about programmatically. Here, we're merely talking about informal specification. I'm not asking you to have, specifications that can be handled in terms of automated reasoning. They're really for us. They're really for us as developers and testers. And there's many types of contracts which have been proposed, and I'm not going to be so specific over what's required. And in general, I don't require that much. You should be aware that there's performance contracts, quality of service. We're going light on that. We're looking for basic contracts involving functionality. And there's a trade-off here between providing too much information and too little information. What's the deal? What would be a benefit for providing a lot of information to users? Providing, you know, a really a lot of guarantees for your implementation. How might that benefit them?
User may easily understand and know what restriction is for you.
Good. So by being clear, for example, and listing these things, they may have greater clarity about what's assumed. And not only that, though, I mean, if you make more promises, it may be that the user can count on more features in your implementation they're otherwise not sure about, and they'd have to use another implementation. On the other hand, if you provide too many guarantees, what does it limit? If you as a developer of an abstraction, of a piece of code, if you provide a lot of guarantees to the users of that code, the people who call it, what are you sacrificing?
Really useful. If you have too many requirements for that code, that means your code only works on some situations, so it might not work on others.
Okay, it could be. Generally, they'll be clearer at least about which it will work in and which it won't. If you leave it up in the air, they might not want to use it because it's not clear, will it meet my needs or not? And even if it does now, how will it change? So they might not use it. Generally, we're not in too worse shape if we're very, very clear about what precisely is guaranteed and provide extra specification of this is, you can count on this, 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 and this. The user generally benefits from that. But whose hands are tied?
The developers.
Yeah, the developers. Now they can't evolve it nearly as freely as they'd like to, because now they've promised all sorts of things. And maybe in the future, for performance reasons, for reasons of integrating with other code bases, because of new technologies, they'd actually like to change how certain things are done. But the code out there could be counting on any of these features they promised in the past. So they're limited in their flexibility of evolving, their flexibility to change the implementation. And at the same time, as was noted, you do want absolutely this sort of clarity on the part who are using it from people from multiple backgrounds to discover misspecifications. So what am I looking for in your code? Here in 371, what are we looking for in these specifications? Well, I'm not looking for anything too fancy, but I'm looking for statements of the higher level purpose of a class or method. And for methods, I want to see preconditions and postconditions. So preconditions are sort of assumptions that the code can make at its start, say this method. And they're often assumptions about, say, the arguments to the method, the things being passed in to the parameters of the method, or about the state of the system when this method is called, right? So when we call this method, we assume the system is already initialized. The database is already populated, or you know, this data structure passed into us is filled, you know, with values. And maybe we assume that this data structure, as I've mentioned before, has no duplicate values in it and no duplicate keys in it, or that all the keys are non-null, or that all the values associated with those keys are non-null. We may assume that this array passed into us has a length greater than 0, or has a length greater than 2. And we may assume that this double precision value passed into us has a value 0 or greater, that it's non-negative, or that this index passed into us is always in the range 0 to the maximum value of the vector that's passed into us. So these are requirements from the method to do its work. It's what I need to guarantee in order for me to do my job as the method. So preconditions. Post-conditions, I'm also looking for you to specify. And these include return conditions. What value do I return, if any? But also things that happen with me. So imagine a method that might have a post-condition, even though it doesn't return a value. Can anyone give an example? What might be something that it's a method, it doesn't return a value, but it has a post-condition that's non-trivial. I mean, that should really describe something. Can you give me a method that would be in that class?
I think that resets the value of a global variable, which might be used by other.
Excellent. Yeah. So it resets the value of a global variable might be used elsewhere in the program. So it modifies some aspect of global program state, right? Okay. Excellent. What's another thing? Today's worlds of UI and network interfaces, databases, there's actually lots of cases where a method might have some post-condition that's different from when it started. It changed the condition of the software, even though it doesn't return a value.
Just displaying something on the screen?
Yeah, it updates the display to show something. Another?
Update the database with new information.
Yeah, it updates the database with some information. How about over a network? Post something via HTTP, right? Via REST protocol, or it goes and sends a message out, a message via the some messaging interface or something like that. Those are post conditions that are part of what a method's job is, and it's not a return value, but it's something that you want to know has happened by the end of the method. And a post condition could be conditional. Under these circumstances, it will send it out in the event of network timeout. No message is sent, but it will indicate, a throw exception will indicate in this way that nothing happened. So I am looking for methods for you to specify preconditions and post conditions, folks. Okay. Now, more than that, there are for classes certain other types of information that's of great relevance and that cannot be reduced to preconditions and postconditions. And there's really two types of quantities here. And I don't have time during this lecture to talk about these. I could do so in another lecture. One of them is invariants. These are things that are true about an instance of this class at any one time. Okay. So again, I've mentioned some of them, right? Things like there's a positive number, a non-zero number of key value pairs within this dictionary. There's some number of keys, and it's greater than 0. This array holds more than one. The array inside the class holds more than one element. Or the array inside the class holds no duplicates. Or the map or dictionary within this class has no duplicate entries in terms of the keys. It may be the fact that a certain variable within the class is always greater than 0. These are properties about the system at any one time that could be verified. Could you write assertions that would check those things? Cannot? Can. Ladies and gentlemen, can. You should be thinking about that. If you have a class which has certain data structures in it, which have properties associated with them, you should be writing code that checks those properties, that that guarantees them. These are called in some areas of literature rep invariants, representational invariants. There are certain things that hold true at any one time of situation. And for the data structure for this class to be in a sane state, we count on those things often being the case. We count on this certain variable encoding an index into some data structure, say a vector, and therefore it has to be a value between 0 and the size of that vector minus 1. We count on this. It's part of our class. Maybe it's a variable in our class, an instance field in our class. And we want to check that it's in a sane state. Because if it's in a whacked out state, it's minus 1 or some value outside of that range, all bets are off. And our code might not work, right? This is not purely reducible to precondition or postcondition for a given method. Often it's a feature of the class as a whole that we want to guarantee. More than this, although it often is guaranteed additionally by the methods, more than this, there are things called history properties, which are not things you could check at any one time, but hold true between two times. Like this value always rises over time. It never decreases, for example. Or once set, this is never removed. Another thing is this may be an immutable data structure. It never changes. That's a history property. The only way you could test it is looking at it 2 different times and seeing if it has the same elements. It's immutable. It's read-only. It's that. Okay. So, ladies and gentlemen, what I'm asking you to think about is putting in place simple statements in the form of specifications for parts of your code. And they lay out, particularly for methods, preconditions and postconditions. Here are some examples, right? Here's a constructor, and it takes in elements, and I want to assert the elements that it takes in are non-null, right? Maybe in other cases, I'd be assuming not only is elements non-null, elements dot size is greater than 0, right? And there might be another thing that's has, for example, another thing that's elements that allows me to iterate over them. Has returns true if and only if the elements and element of the set represented by this. Okay, so simple notion. Now, a few points that are easy to miss about this, but pretty important. You don't have to write, and you should avoid getting trapped into thinking that you have to write the preconditions and postconditions of each method in isolation of the others. Often the preconditions of one method or postconditions of one method will actually mention within those preconditions or postconditions information about values returned or actions performed by different methods. Okay, so an example here would be an integer set here, where you have a has method and you have an insert method. And you'll notice the insert has as a precondition not has of x. So if I go to insert x, what is this saying, basically? If the precondition is not has, what is this saying? Yeah. So the thing that I'm being asked to insert should not already be in here. And you'll notice how I'm saying it should not already be in here. I could write it out longhand, but it's just easier to just say, if I called has on it, it's not true before, right? By the way, that just sets up. This is like, it just sets up a perfect time for an assertion, right? You just assert this coming into here, not has of that. Remember, the assertions are stripped away. You can just strip them out of your running code. You just hit a compiler flag, and they'll be stripped out of the code that you are going to distribute on to clients post testing or what have you. So you can assert this at no cost to your final program, but at a lot of benefit for debugging, at a lot of benefit for testing. Okay. Similarly, the post condition here is has of x. Does that make sense? That if I go insert something, it can't be in there already, and after I've inserted it, it is there. Right? And this is defined in terms of this has. Similarly, remove, there's no precondition. I can request removing something that's not in there, is what this is saying, right? There's no precondition. So I can call this on something legitimately that's not in there. But what is guaranteed is, regardless of whether it was in there or not up front, this allows for both, the no precondition. After it runs, it's not in there. After this finishes, it's not in. Do you understand that? Do you appreciate that? Okay. And similarly, I could have sort of union and subset and so on. This is the sort of thing I'm looking at. Sometimes these things get a little bit more wordy, which is fine. So my read-only dictionary here. Okay, so I take two things in as arguments. What are the preconditions here? Can anyone unpack these? I mean, I've written them in a bit of a mathematical notation, like you might have seen in 260. So what is this first precondition saying? So I'm passing in my read-only dictionary. This is a constructor. I'm passing in some keys and some elements. What's the first thing saying?
There's a one-to-one mapping between the keys.
Yeah. There's at least there's an equal number of keys and elements, right? And yes, it's reflecting a one-to-one mapping. And what is the second one saying? Keys of I equals keys of j. That's referring to these keys, if and only if I equals j. There's no duplicates. There's no duplicates in keys, right? Okay, how about the third condition? Notice keys are strings. So what is this third condition saying?
Not null and empty.
That's right. So these strings, and actually this should be 0 less than or equal to I, and less than key subsize. Keys of I. So this is saying basically these strings are not null, and they are not just empty string. They're not just have 0 length, right? So that's the precondition. Now, for this class, do I want you to write everything like that? Not necessarily. I mean, some people, and I have to confess, I mean, myself included, I mean, I find that have a certain clarity. If you want to write that out in English, there can be no duplicates among the keys. All keys have to be non-null and of length greater than 0. I'm perfectly happy with that. Give you a gold star if you do every method in your code base with that. I'll be one happy camper. So, ladies and gentlemen, the post condition here. So then I say, it's a set representing map from keys to the corresponding elements, and this is the point Matt Moon made, that it's. You notice I say keys of I to elements of I, so it's a one-to-one mapping sort of there for them. Okay. So ladies and gentlemen, make me a happy camper. Okay. Make me a happy camper. I know this doesn't come for free, but it pays itself back. It doesn't come for free up front, but it pays itself back, because if you have these sort of things, you're just opening the floodgates for people to write some tests against your code, even before you've written it. You should be able to write these things before you write your code. The tests will fall out of them. The assertions will fall out of them. And you're going to be able to have other people writing other parts of your program who will know basically what is guaranteed by your code, and be able to write their code soon in parallel with yours. So you decouple them saying, are you done yet? Are you done yet? With your code. So does it cost something? Yeah, up front. But the investment way more than pays itself back. But maybe I'm better off saying, make me a happy camper. Okay. So there's many ways for putting these in place, and I'm actually not too particular. I gave precondition, postconditions, invariance, history properties. But the fact is there's others out there who would use preconditions, effects, and invariance. And you'll find, quite a literature on different different sort of ways of performing these things. You will also find them in some libraries that you folks use in their different forms. So this is an effects thing. And effects basically is going to describe going from preconditions to postconditions, what changes, what sort of is modified there. So rather than separately specifying, postconditions, it's specifying with delta, as it were, the effects that this undertakes. So this is an example from that Lisko type book. If you have either of these two things are null, it'll throw an exception. This thing's the empty string, throw a different exception. You notice how it specifies this: if S1 occurs as a substring of this, returns the least index in which S1 returns, otherwise return -1. So it actually specifies a set of conditions, including exceptions that can be thrown. That's part of the effects, or that's part of the post conditions, that an exception may be thrown. Not just insert into database, send messages out, GUI updates to global variables. All those are excellent, but exceptions are part of that. And you'll notice what it finishes with, and this is a key point I'd like you to think about, is it finishes with some examples of how the code is written. Why do I say it might be easy to specify those examples if you've made me a happy camper?
Know exactly what it has to cover.
Good. And what might you be doing as part of this class that would make specifying examples like this as part of the documentation particularly easy? Or let's put it this way, they kind of go together. What do these kind of look like? You squint your eyes and you put these into JUnit, this would start to look like a what? Begins with a T, ends with a T. Yeah, test. Test case 1, test case 2, right? So some of those examples could be rendered into tests very easily, or tests could be put up here as documentation along with it. But these often, look, we're all developers here, right? We're busy. We value documentation about the code we're looking at. Sometimes we'll go through it in great detail. But often at the end of the day, we're also interested in quickly refreshing our memory or acquaintance with basically how do you use this, right? And this gives some idea of how to use it. And once again, I would argue it pays itself back. It's an investment that yields returns way out, way greater than what you're putting in there. Because it will allow people in the team to work much more efficiently, to pester you less via email or over Slack or Trello, what have you, to sort of poke you about how to undertake this. And there's some guidance out there you'll find about how to do these, how to describe these things well. This, for example, comments that this is somewhat ambiguous. So here's subset S1, S2. We're asking if one is a subset of the other, and notice the effects. If S1 or S2 is null, throws this exception. Otherwise, returns true if S1 is a subset of S2. Otherwise, returns false. Why is that ambiguous? Why do I say that's ambiguous? When I say subset, colloquially, if I'd said that in 260, subset, is this a subset of S? So is S1, the set including S1, a subset of the set of S1 and S2? You would say yes, right? What's not so clear?
They're both null, then this one's technically subset.
Oh, okay. So that's well, yeah. Here it says if either is null, but I might ask is 1 and 2 a subset of 1 and 2? Is that a subset? Yeah. Is it a proper subset? No. And someone who's reading this might be interested in knowing, okay, does this mean a proper subset or a subset? And it's not totally clear. Here, it's actually explicated more, for example. Returns true if S1 is a subset of S2, i.e. returns true if every element of S1 is an element of S2, otherwise returns false. So sometimes it's actually useful to phrase it in two different ways, not unlike requirement solicitation, if you think about it, right? And you have to realize that if you start going globally, and Canadian products, software products are often most successful when they have global penetration. You have to realize that people work in different systems globally, right? Here, rather than saying returns true if temp is less than 0 degrees Fahrenheit, other returns false, you could head off misunderstandings or bugs that would suggest inconsistencies. Here it says returns true if temp is less than or equal to 0 degrees Fahrenheit, otherwise 1, i.e. returns true exactly when temp is not greater than the freezing point of water at standard temperature or pressure. Why is that a problem? Why is there an inconsistency here?
It says 0 degrees Fahrenheit, but then it changes to the freezing point of water.
Right. So something isn't jiving here. Either this is 0 degrees Celsius, or we're talking about 32 degrees Fahrenheit, or this last statement is not true. And it can point out those inconsistencies sooner if you're a little bit more wordy. Similarly, if you look at how certain terms are used, like billion, it's used in different contexts in different countries. And in Britain, billion is used in a different context than it is in North America. Okay, so putting in a bit more explanation, i.e. this, or giving an example, can really head off some understanding. Okay, that's all we have time for today. Thank you very much, folks. I have one final request. I'm going to be setting up in a Google sheet, a sheet which I'm going to share with each of the project managers for the 4 teams. Okay, and what I'd like you to put into the sheet is, for each time there's a designated inspection or an inspection done during the project meeting times on Tuesdays, you let me know when it is, where it will be meeting, and who is expected to be there or is there. Okay? I've been able to drop by several of them on a casual basis. And I just want to be sure that I'm aware of others as well, so that I can use it to judge who's actually participating, in going to these things, etc. Okay, and I'm asking you to do that for the ones that are in that Tuesday slot. Okay, if you have them elsewhere, that's fine, but I'd like to be able to have the option of dropping by. Thank you very much.
With regards to kind of, I know we didn't talk about this in 4.7.